Welcome to the deep dive. Today, we're diving into a really fascinating shift happening in AI, microlanguage models.
Mhm.
You've probably heard about the massive large language models, right? The ones making headlines.
Oh yeah, they're hard to miss.
But we're here to explore their smaller, maybe less famous, but really significant cousins.
Exactly. This deep dive is all about unpacking what these micro LLMs are, why they're suddenly, so important, and looking at some of the surprisingly powerful ways they're being used.
Right.
We've got a pretty comprehensive analysis here, and our mission really is to pull out the most crucial, the most interesting insights, give you a clear picture of these, well, smaller, but definitely mighty AI models.
Without getting lost in the technical weeds.
Precisely. No swimming in jargon today.
Okay, let's get straight to it then. Micro LLMs, the name's pretty clear, they're small, but like in the AI world, what does small actually mean and why should we care?
Well, okay, so micro LLMs are basically a specialized type of what we call small language models, SLMs for short.
SLMs, right?
Think of SLMs as AI models trained on data sets that are much smaller and more targeted compared to the huge amounts of data used for LLMs.
Okay.
And this focused training lets micro LLMs become incredibly precise, really effective, but within very specific areas.
So like an LLM tries to know a bit about everything.
Kind of, yeah.
Yeah.
Whereas a micro LLM aims to know a lot about one very specific thing.
Gotcha. So if LLMs are the Swiss Army knives, these are more like specialized scalpels.
That's a great analogy, actually. Yeah. And when we talk size, the key thing is the number of parameters, essentially the knobs the model learns to tweak during training.
Parameters.
Generally, models with fewer than, say, 30 billion parameters are considered SLMs. And interestingly, some recent research even suggests that for a lot of language tasks, models under 8 billion parameters can be really effective.
8 billion.
Yeah, though you might see some definitions stretch that up to maybe 13 billion or so.
Okay, but billion still sounds like a huge number to me.
It does. It absolutely does in isolation. But it's all relative, right?
Compared to the big ones.
Exactly. When you stack it against the hundreds of billions, maybe even trillions of parameters in those LLMs making the news.
Okay, now I see why they're called small.
Right. And the big driver behind this focus on smaller models is practicality, making them easier to deploy, more affordable, and really nailing performance for specific needs. It's kind of moving towards truly personal AI.
Personal AI, like on your phone?
Yeah, potentially. Powerful language processing, not just in the cloud, but, right there in your pocket,
Yeah.
enabling things we couldn't really imagine before.
That makes a lot of sense. It feels like we saw this in other tech areas too, right? From giant mainframes down to PCs. But for a while in AI, it seemed like the only way was bigger, bigger, bigger.
You've definitely hit on a key point there. Historically, there was this strong belief that bigger AI models, more parameters, more data, just automatically meant better performance.
The go big or go home philosophy.
Pretty much, yeah.
So what were the downsides of just, relentlessly chasing scale?
Several pretty big ones, actually. First, the sheer computational power needed. Training and running these huge models, it costs a fortune.
Eye-watering costs, I bet?
Absolutely. Then there's latency, the delay in getting a response. That's a killer for real-time stuff.
Right, you can't have delays in some applications.
No way. And we can't ignore the environmental impact. The energy needed just to train something like GPT-3, estimated around 1,300 megawatt hours.
Wow, that's staggering. Like powering a small town, you said.
It really puts it in perspective. And this
Wow.
democratization isn't just about cost saving.
Yeah.
It lets smaller players, individual developers, innovate without needing massive infrastructure.
Leading to maybe more niche tailored solutions.
Yes, exactly. Things we haven't even thought of yet.
So SLMs, and specifically these micro LLMs, are really stepping in to tackle these problems. It's about smart efficiency, not just brute force size.
That's a good way to put it.
This whole scale versus efficiency thing, it's not just jargon. It's about making AI more accessible, more sustainable.
For a much wider range of uses.
Okay, so we're seeing the advantages. Now let's draw a clearer line. How do they really differ from the big LLMs we know? What are the core distinctions?
Okay, several key differences. Let's start with the basic architecture and parameters.
Right.
We touched on it, but for comparison, a micro LLM like Phi-3 Mini, around 3.8 billion parameters.
Okay.
Mistral's Mixtral, it's interesting. It has an 8 billion parameter base, but uses this clever mixture of experts thing.
Mixture of experts.
Yeah, where only about 39 billion parameters are actually active for any given task. It's like having a team of specialists inside the AI.
Huh, interesting. Like it writes the query.
Exactly. It sends the question to the expert best suited. Now, contrast that with, say, Llama 3.1 with 405 billion parameters, or GPT-4, which is rumored to be even bigger.
Whoa. Okay, that is an astronomical difference. And the active parameters in Mixtral, why is that so significant?
Well, it shows how SLMs can get really impressive performance without just raw size. These architectures, like Mixture of Experts, let the model selectively activate parts of its network.
Like calling on the right specialist from that team you mentioned.
Precisely. So it can have a large overall potential capacity, but uses resources very efficiently. It really challenges that simple idea that more parameters always equals better.
Got it.
And while, fundamentally both SLMs and LLMs use transformer architectures, the SLMs often have specific tweaks, optimizations for their smaller size.
Smart design. So what about the actual resources? The hardware, the time needed to train and run them?
Oh, the contrast is stark. Training an LLM, it's massive. Thousands of powerful GPUs running nonstop for weeks, months even.
You mentioned GPT-4, 25,000 GPUs for nearly 3 months.
Yeah, the report suggests something like that. The cost, the energy. It's frankly mind-boggling. And even just using a trained LLM inference, we call it needs serious compute power, usually big cloud setups.
Which gets expensive and can add delays, right?
Definitely. Especially with lots of users.
It almost sounds like only the tech giants can really afford to build and run those huge models. Does this lower resource need for micro LLMs genuinely level the playing field?
Absolutely. That's a huge part of their appeal. Because they're smaller, micro LLMs need way less computational power for training and deployment.
Which means lower costs.
Significantly lower costs, yeah. And a key thing is they can often run pretty well on more common hardware. Standard CPUs, smaller graphics cards, even the chips in edge devices like phones.
So the barrier to entry is much lower.
Much lower. That's really driving adoption. Plus, cloud providers often charge per token for LLMs.
Right, per word generated.
Yeah, and that can get really expensive, really unpredictable. SLMs offer a much more cost-effective, predictable way. And importantly, less energy use means they're more environmentally sustainable.
So, lower initial costs, lower running costs, and a smaller environmental footprint. That's a compelling package.
It really is.
Okay, but how do they actually perform? There must be trade-offs.
Yeah.
Right? In capability.
You're right. There are definitely trade-offs. LLMs, the big ones, they're built for broad general knowledge, versatility. They can tackle a huge range of tasks, often excel at complex, open-ended stuff that needs pulling info from many places.
The jack of all trades.
Kind of, yeah.
Yeah.
Micro SLMs, though, are laser-focused, trained on narrower data, so they get exceptionally good within their specific domains.
But they lack the general knowledge.
Typically, yes. They don't have that wide-ranging world knowledge. But here's the interesting part. If you fine-tune an SLM for a very specific niche task, say, analyzing financial reports for one particular type of fraud, it can often outperform a much bigger LLM in accuracy and relevance just within that narrow area.
Wow. So master of one trade beats jack of all trades for specific jobs, and you mentioned using them together.
Exactly. We're seeing this trend towards AI ecosystems or hybrid setup.
Hybrid. How so?
The idea is you have specialized micro LLMs handling the routine domain-specific stuff where they're super efficient and accurate. And maybe they work alongside larger LLMs for more complex reasoning or when you need that broad knowledge.
Like a team of specialists backed up by a generalist.
That's a good way to think about it, yeah.
Makes sense. Use the right tool for the job. Okay, one more area I'm really curious about. Data privacy and security. We hear so much about risks with big models. How do micro LLMs stack up?
This is a really compelling advantage for them because they can often be deployed locally on a company's own servers or even right on individual devices.
The data doesn't have to leave.
Exactly. Sensitive data can stay under much tighter control. That massively reduces the risk of exposure compared to sending everything off to a cloud API.
Which helps with regulations like GDPR too, I imagine.
Absolutely. It aligns much better with data protection rules. Plus, their focused nature might even make them, a harder target for attackers in some ways. For orgs handling sensitive info, this privacy and control is a potential game changer.
That local deployment sounds fantastic, especially with data breaches being such a concern. Are there any downsides, though, to not using the cloud's massive data sets and power?
Well, the main trade-off is that lack of broad general knowledge we talked about. If you need an AI that can answer any question on any topic, a locally deployed micro LLM probably isn't the right fit on its own. But for specific tasks, The privacy benefits often outweigh that limitation.
Okay, so summarizing the core advantages. We've got efficiency, lower latency, cost effectiveness, resource optimization, high customizability, domain specificity, and better privacy with on-device options.
It's a pretty good list, yeah.
It's powerful. Let's dig into why some of these are so critical. You mentioned lower latency. Why is that such a big deal?
Low latency, that instant response, is just crucial for so many real-time things. Think autonomous vehicles. They need to process sensor data, make decisions in milliseconds.
Can't wait for a round trip to the cloud.
No way. Or robots in a factory reacting instantly to changes. Any delay is unacceptable, potentially dangerous. Micro LLMs running locally, right on the device, can provide that immediate reaction.
And you mentioned optimizations, too.
Yeah, things like specialized hardware, low-precision tensor cores, they're like dedicated fast lanes for AI math on the chip, help speed things up even more.
Right. No pausing the self-driving car to ask the cloud what to do. Okay, what about the cost savings? Can you give us a better sense of how significant they are?
They can be really substantial. Comes from multiple angles. Less compute needed for training means lower hardware costs, lower energy bills.
Right.
Deploying on cheaper hardware saves money too.
Right.
And a cost structure is just more predictable than those per token charges for LLMs. It makes budgeting much easier.
Which opens the door for smaller players.
Totally. It democratizes AI development. Smaller businesses, individual developers, they can actually afford to build and deploy these tailored solutions. We might see innovation from places we wouldn't expect.
And that customizability, that sounds like a massive plus for businesses with specific needs. How does being domain-specific give them such an edge?
Well, by focusing on one area, trained on curated, high-quality data for that domain, they achieve much higher accuracy and relevance within that area.
Less noise, more signal.
Exactly. They avoid some of the irrelevant stuff you might get from a broad model. Plus, they're generally much easier and faster to fine-tune with a company's own data.
Using their proprietary knowledge.
Right. Building tailored AI solutions that give them a real competitive advantage. And because the training data is focused, they're often less prone to hallucinations making things up compared to some larger models.
Interesting. Okay, finally, let's circle back to privacy and on-device deployment. Seems like a major draw.
It absolutely is. Keeping sensitive data in-house on your own servers or on the user's device. Huge benefit, especially for regulated industries. Simplifies compliance, reduces breach risk.
And the on-device AI part.
That opens up a whole new world. Imagine your phone doing complex stuff, real-time translation, understanding voice commands without needing the internet constantly.
Faster, more reliable, more private.
Exactly. Not dependent on network signal or bandwidth. This whole shift towards edge AI, it's expected to be a major driver of innovation, maybe even push us to upgrade our devices more often.
It's really clear these aren't just scaled-down LLMs. They have their own unique power. Okay, let's talk about where they're actually making a difference. What are some specific industries, some real-world uses?
Oh, the range is already pretty wide and growing fast. Take finance. We're seeing micro LLMs used for automating customer service chats, sifting through internal documents, providing personalized advice.
Fraud detection, too.
Yeah, fraud detection, risk assessment. In pharma, they're helping generate research reports, manage financial oversight, optimize clinical trials.
Okay, manufacturing.
Manufacturing's big, too. Quality control, analyzing sensor data, visual feeds, predictive maintenance, figuring out when machines might fail before they do, optimizing production lines.
Makes sense. Insurance.
Claims processing automation, that's a huge one. Plus fraud detection, again, risk assessment. Lots of overlap in the needs there.
What about healthcare? That seems like a really promising area.
Healthcare is incredibly exciting. Edge deployment is huge here. Analyzing patient data right at the point of care, almost instantly. Vital for quick decisions and keeps data private.
Like Google's MedPolM you mentioned.
Exactly. Models like that show the potential. They're also streamlining workflows, transcribing doctor's notes automatically, generating visit summaries, billing codes.
Taking away administrative burden?
Right. And even supporting research by quickly analyzing massive amounts of medical literature.
So beyond these big industries, are they popping up in more everyday things we might use?
Definitely. You're probably interacting with them already without realizing it, like text completion on your phone.
Oh, yeah, predictive text.
That often uses smaller models. Language translation apps, the good ones that work offline. Those two. Customer service chatbots are getting much better thanks to them.
Okay. What else?
Behind the scenes, things like sentiment analysis, understanding customer feedback online, data analysis for market trends, optimizing marketing campaigns.
Content creation, too.
Yeah, helping draft articles, reports,
Yeah.
and coding assistants like GitHub Copilot. They rely heavily on smaller, efficient models for those real-time code suggestions.
Personalized recommendations.
Yeah, but news apps, shopping sites often powered by these efficient models to tailor things just for you.
Wow. So they're becoming pretty integrated already. Often invisible, but there.
Pretty much.
You mentioned edge computing again. Can you give more specific examples of those real-time on-device uses?
Yeah, edge is where they really shine. Autonomous driving, processing local sensor data instantly for those critical split-second decisions. Can't rely on the cloud for that.
Right. Robotics.
Robotics, too. Low latency control for navigation, grabbing things, reacting to the environment. Again, cloud delays are a non-starter.
What about IoT? All those smart devices.
Exactly.
Right.
Enabling devices to understand commands locally, communicate more effectively without need in constant cloud chatter, makes them more efficient, more responsive.
And our phones.
Our phones are becoming major edge devices, real-time translation during calls, personalized experiences based on local context, all happening right there.
With industrial settings, too?
Yep, industrial IoT.
Mm-hmm.
Predictive maintenance on machines, anomaly detection right on the factory floor, saves downtime, boosts efficiency.
AR and VR.
Augmented and virtual reality, yeah. Powering instant personalized interactions in those immersive worlds. Makes them feel much more alive and responsive.
You highlighted a few specific models earlier, like Phi 3 Mini and Mixtral. Any others that really stand out for their capabilities or approach?
Well, those two are great examples. Phi 3 Mini showing how incredibly compact you can make a capable model,
Yeah.
even fitting it on phones with strong multilingual skills.
Right.
And Mixtral 8x22B with that mixture of experts really pushing performance and efficiency, great at math, code, general knowledge, but still cost-effective. They just showcase the different ways developers are optimizing these smaller models for different jobs.
It's amazing the breadth of applications and the cleverness behind these models. But like any tech, there have to be downsides, right? Limitations, challenges.
Oh, absolutely. Despite all the advantages, they do have inherent limits, that focus we talked about. It means they're not great at generalizing outside their training area.
So the financial model won't help with medical summaries.
Exactly. They're less suited for those broad, general-purpose tasks where you need understanding across many fields. And their reduced complexity can sometimes mean they struggle with really nuanced, intricate problems that need deeper context. LLMs often still have the edge there.
Okay. What about bias? We hear so much about bias in the huge LLM datasets. Are micro LLMs immune?
Not immune, no. While using smaller, more curated datasets can make it easier to spot and fix biases compared to the wild west of internet data LLMs use. The risk is definitely still there. If that smaller dataset isn't carefully chosen, if it's not representative, it can still bake in biases. Underrepresentation, inaccuracies, stereotypes.
So the output can still be skewed or unfair?
Absolutely. So you need rigorous attention to data quality, diversity. It's crucial to limit bias and also, factual errors or hallucinations. The focus has really shifted in SLM development quality over just quantity of data is key.
That's a really vital point. Smaller doesn't automatically mean fairer. Data curation is critical. What about the practical side? Running them on those resource-constrained devices you mentioned, is that still tricky?
It can be, yeah. Even though they're optimized, they still need decent compute power to run well, especially on really limited hardware like tiny embedded systems or older phones.
They might lack the processing power or memory.
Exactly. Memory, storage space are often tight. There's also the overhead of getting the model onto the device, potential network delays if it needs updates, and energy efficiency is huge for battery-powered devices.
Right, can't drain the battery instantly.
No. Even transferring a compressed model can take time over some networks. So, yeah, successful edge deployment really depends on developing the models and the specialized hardware together. They have to co-evolve.
So it's a two-way street. Making models leaner, making hardware more capable. That leads us to the techniques for bridging that gap. What are the key strategies for optimizing and deploying micro LLMs?
Okay, a big area is model compression, making them smaller, faster, without losing too much performance. 3 main ways.
Right.
First is knowledge distillation. You train a smaller student model to mimic a bigger, smarter teacher model.
Like transferring the knowledge.
Sort of, yeah. Transferring the essential reasoning. Second is pruning. You identify and snip out less important connections or parameters in the model's network, like trimming a bush to make it more compact.
Okay.
And third is quantization. reducing the precision of the numbers the model uses.
Yeah.
Fewer decimal places, basically. Makes the file smaller, computations faster.
Clever ways to shrink them down. Are there also specific ways to train or fine-tune them more efficiently?
Yes, definitely. Fully retraining even a small model can still take time and resources. So more efficient fine-tuning methods are popular.
Right.
One big one is LoRa low-rank adaptation. You only tweak a small fraction of the model's parameters during fine-tuning. Much lighter, much faster.
Okay.
There are also things like adapter modules adding small extra layers that you train for the specific task, or prompt tuning, where you focus on crafting the input perfectly to guide the model, rather than changing the model itself much.
Interesting. What about training data?
Well, a fascinating trend is using LLMs to generate synthetic data to train smaller models.
Using big AI to teach small AI.
Kind of. Creating high-quality targeted data allows even smaller models to perform really well on specific tasks. Of course, large web data sets are still used for foundational training too.
And you mentioned they can even help speed up bigger models.
Yeah, through speculative decoding. The smaller model makes quick guesses about what comes next. The bigger model checks them, speeds things up.
It's like a whole ecosystem of techniques working together. What about actually deploying them, setting them up in real systems? Are there different ways to structure that?
Yeah, several common patterns. Simplest might be monolithic, the whole AI system in one block. Good for maybe prototypes.
Okay.
More common for complex stuff is a microservices architecture. Breaking the AI down into independent bits, prompt handling, the model itself, output processing that talk to each other, more flexible, easier to scale parts individually.
Makes sense. Any others?
There are hybrid approaches mixing those. Pipeline architectures, where data flows through distinct steps, and adapter patterns for plugging the model into existing software nicely. But whatever the pattern, deployment needs careful design, testing, security, and ongoing monitoring.
And managing all those pieces.
For large scale, tools like Kubernetes are often used. Container orchestration helps automate deployment, scaling, managing all those moving parts.
Wow. A lot of sophisticated engineering goes into making these work effectively in the real world. So looking ahead now, what are the big trends, the exciting prospects for these smaller AI models?
Well, one massive trend is definitely the continued rise of edge AI, that on-device intelligence.
More AI on our phones, in our cars.
Exactly. The push for real-time processing, better privacy, efficiency, it's driving more AI directly onto devices. Big players like Apple, Qualcomm, they're embedding micro LLMs directly into their chips.
So AI becomes just a standard local feature.
Increasingly, yes, leading to new experiences and probably driving hardware upgrades too.
What about broader AI trends? How will they affect micro LLMs?
Good question. Multimodal fusion is a big one. AI getting better at handling images, video, audio, not just text.
So micro LLMs could understand pictures or sound too.
Potentially, yes, making them way more versatile. Think smarter assistants, better sensor analysis. Another huge area is autonomous agents.
Agents, like AI that acts on its own.
Pretty much. AI systems that can plan tasks, take initiative, learn, improve. These agents often rely on efficient language models like micro LLMs as core components for understanding, planning, interacting.
That sounds like a major step change. What about the underlying tech, hardware, connectivity? How will that shape things?
Oh, crucial. New hardware ideas like photonic computing using light promise much faster, more efficient computation.
Which would boost micro LLM performance.
Massively. And neuromorphic computing, mimicking the brain, could slash energy use, making on-device AI even more practical. Then there's connectivity.
6G.
Yeah, 6G is on the horizon. Super high speeds, ultra low latency, essential for distributed AI, where lots of devices and models work together seamlessly.
So powerful local micro LLMs plus super fast networks.
Exactly. That combination unlocks amazing potential for intelligent ecosystems, super responsive systems across all industries.
It really sounds like we're on the verge of some big shifts. So bringing it all together, what's the big picture for AI? This balance between the giants and these smaller, specialized models.
The future looks like strategic diversification. We'll still see investment in big foundational models, no doubt. But there's this growing realization of the massive value, the practical need for these smaller, efficient models across countless applications.
The sheer size isn't the only answer anymore.
Right. And recent surveys are showing well-designed SLMs can match much larger models in specific areas. So the future is likely more nuanced. Choosing the right AI for the job balancing performance, efficiency, cost, scalability.
And research keeps pushing what micro LLMs can do.
Constantly. They'll keep getting better within their specialties.
This has been incredibly insightful, a real deep dive into micro-language models. It's so clear they're not just, a side note. They're a vital, powerful part of the AI picture, offering these unique advantages: efficiency, cost, privacy, specialization, and the fact they can run anywhere, from the cloud down to tiny devices. It's unlocking so much innovation.
Absolutely. It really is transforming things across industries and our daily lives.
Which leads to a final thought, maybe?
Go for it.
Well, it makes you think, doesn't it? As these specialized microbrains become more common, embedded in our phones, our homes, our workplaces, how does that fundamentally change how we interact with technology, how we work?
Yeah. What new possibilities, maybe even what new challenges arise when intelligence becomes that distributed, that integrated into everything?
Something definitely worth considering. If you found this as fascinating as we did, we really encourage you to explore some specific micro LLM applications that connect with your own interests.
For sure.
Thanks for joining us for this deep dive.